Hi, welcome to our second video for 4.2 coterminal and related angles. In this example, it says relations for cosine and tangent ratios. So let's look at part A. It says determine another angle between 0 and 360 that has the same cosine as angle A in example 1. What is the relationship between this angle and angle A? So if you remember from the example A, we had angle A out here, and we had that ordered pair. The opposite value was 3, the hypotenuse was 5, and the base was 4. So we had the ordered pair 4, 3. So this is for angle A in the first example. So it says find another angle between 0 and 360 that has the same cosine as in example A. So if you remember, cos of A is equal to 4 over 5. This is positive. Okay, it's positive because the x value is positive here. So where could I have another angle where I get the same ratio 4 over 5? So meaning x must be 4. Why? Y doesn't have to be positive 3. It could be negative 3. So if I go out here, my x value is going to become negative, and that's no good. I'll get a negative cos ratio. Same with out here. Okay, these ordered pairs, they all have negative x's. It's not unless I'm down here that the ordered pair for this is positive for x. So I know I must be in the fourth quadrant. Okay. So cos of angle A is positive. So we can say the angle, with an equivalent cosine must be in the fourth quadrant. Okay, that's the only other place where x is positive. So in order to have the same ratio, 4 over 5, it also needs to be the same triangle. It needs to be congruent, and it also needs to be somewhere down here. So what we can do is we can kind of cheat, and we can reflect this along the x-axis, and we would have the point 4, negative 3. And there's my new triangle. It has a hypotenuse of 5. The y value is negative 3. And the base is still 4. So I can still get the ratio of 4 over 5, the same cosine. Let's label this angle here. I'm going to call it alpha. Okay. So we can say here sine of alpha, it's going to equal y over r. So the y value is negative 3, the hypotenuse is 5. Cos of alpha, x over r, x is still positive 4, hypotenuse is still 5. Tan of alpha, y over x, it'll be negative 3 over 4. So those are my three primary trig ratios. For a second angle that also has the cosine of 4 over 5. Okay, what is the relationship between this angle and angle A? Well, we could say that angle alpha, is equal to 360 minus angle A. 360 minus angle A. Okay, how do I know that? Well, I know that this angle here is also equal to angle A. So all the way around is 360. 360 minus this angle A gives me what's left over, alpha. So this is the relationship for that. Okay, part B, determine another angle between 0 and 360 that has the same tangent as angle A in example 1. Now we want the same tangent ratio. So tangent of A, I'm going to first write that out. It would have been 3/4. So where else can I get a positive tangent ratio? So if you recall, tan is y/x. So that means when I divide y by x, I get a positive value. So the only way tan is positive is if we're out here, where x and y are both positive, or down here, where my my y value and my x value are both negative, and the negatives cancel out. So we can say the second angle must be in quadrant 3 because its tangent needs to be positive. Okay. So I'm going to erase the old stuff here for alpha. So my new angle this time needs to be down here. How am I going to draw this triangle? Well, the triangles need to be congruent in order to have the same trig ratio. So what that means is this side length has to be the same as this, and this side length has to be the same as this. And they need the same hypotenuse too. So basically what I'm doing is I'm reflecting this over the y-axis, and then I'm reflecting it over the x. Okay. What are my side lengths? Well, this y value would be -3, and the x value would be -4. The hypotenuse is still positive. So now I have congruent triangles. This angle in here is basically angle A. So what's the actual angle of this terminal arm? Well, we always measure from the positive x-axis and go around. So we're going to call that, we'll switch colors, and I'll call that beta for the angle. Okay. So we'll go back to green and we'll write out our trig ratios. So sine of beta, it's going to be y/r, so it'll be -3/5. Cos of beta, x/r, and that will be -4/5. And then tan of beta, that's y/x, so it's going to be -3/4. The negatives cancel, and I just get 3/4. That's how I get the same tan ratio as angle B. Okay. I think it asks what is their relationship. So remember how we said these angles need to be the same. So what's angle beta? Well, angle beta we could say is actually 180. So go to there, plus angle A. So angle beta is equal to angle A plus 180 degrees. Okay. If we wanted to actually calculate angle beta, we already found angle A in the previous question. Okay, remember we said angle A was 37, so I can actually use that to get this angle. I could say 37 plus 180, and that gives me 217. Okay, let's check. Let's see if tan 217 equals tan of 37. Tan of 37, and then we have tan of 217, and we can see they're the same trig ratio. So basically what we want to take away from these last two examples is in order to get equivalent trig ratios, you need to pay attention to where those trig ratios are positive. So if I'm supposed to have two angles that have the same sine ratio, remember sine is always related to y over r. So they need to have the same y value. So if my first angle is up here, that means my other angle needs to be up here as well. And they need to have the same y value. If they say they need to have the same cosine, well, that means they need to have the same x value. So that means one could be up here and the other one could be down here. That way they have the same x value. And for tan, well, tan is y over x, so that ratio needs to stay the same. So here, y over x is 3 over 4. Well, down over here, our y over x, the negatives would cancel, and we would still get 3 over 4. Okay, that concludes our second example. See you guys in the next video.